if a charge particle moves in a plane or somewhere that one, so what is the magnetic field that? So I'll go back to this one, d bar equal to mu naught I dl bar cross r cap by 4 pi r square. And this was that current element. There's a wire. And this was that current element, we assumed it. And there's a current I. There's a position vector r cap. At this particular point P, we have defined it d bar. So what is that current I? So can we write dq by dt? And dl is this one. Actually, who will flow? So shall I say some positive charge is going to flow here with a speed v. So the same formula, I'll modify it. Mu naught I is what? dq by dt. dl by dt. dq I'll take outside. Four pi r square. So this will be mu naught dq. What is dl by dt? I think the charge particle should pass through that current element. It will have a speed dl by dt, means it will have speed v bar cross r bar 4 pi r square. dq is what? You can put charge here. So therefore b bar equal to mu naught charge q v bar cross r cap by 4 pi r square. A moving charge particle will generate magnetic field. Means like we studied capacitors, we studied current density there, the current I was flowing, and we took about which energy? Only electrostatic field energy, no? We didn't bother any other energies. Means definitely we did a lot of wrong. Of course, we have to add correction. Practically, when you go it, no, when a current I flows in a circuit, there'll be also magnetic field, no? According to now what we know, that magnetic energy also should be considered. So like this, as you keep on add up the content for your physics, no, you are going to add corrections. Current electricity chapter, what we discussed is some error is there. Small corrections are to be done. What is that? Even the magnetic field energy should also be brought into the circuit, because any current carrying wire will have magnetic field, and where all the field is there should be magnetic field energy present. The moving charge particle will produce magnetic field. This magnetic field, what happens? Sir, inside electron moves inside the current. Will it produce magnetic field? Yes. There will be magnetic field. So now the current density will slightly have to be modified when you consider the effect of this magnetic field generated due to moving charge particle. And there'll be also electric field applied potential difference due to that, and the action of E bar and B bar. So the way what we assume, little bit changes have to be made. So in general passages, they may ask you something this one. So try to go back to current density. Definitely the way we did problems, no, slight modifications are to be done. So in general pages, they'll try to stress all these things. But if they ask you specifically about, if they give mu naught value in a question, consider the effect of magnetic field. Otherwise, current density means only current I is flowing, it will be generated. No, if a like a field at point P, suppose if a charge particle, if it is moving along, so charge particle is there, it is moving with a velocity v. So what about the field strength at point P1, then at point P2? At P1 it should be 0, no? Any reason for that? Because this is the vector R1 bar. What is the angle between V bar and R1 bar? Parallel to that. So field strength at point P1 will be 0. What about P2? For that, what you should draw a position vector R2. Then you must get this angle theta 2. Then the formula will be BP2 should be equal to mu naught QV sine, angle between that will be sine theta 2 by 4 pi R2 square. If I give this is A and B, no, you can calculate R2. R2 square is equal to A square plus B square. What about sine theta 2? Sine theta 2 is equal to B by root of, like this you can calculate the field. Okay, this is about the due to moving charge particle. Now, when they produce the field. So now what about the direction here? How to predict the direction out of the plane? How do we can see? How to say the direction? R bar cross V, because according to this, oh, sorry, V bar cross R, according to the formula V bar cross R, curl fingers at point P2 from V bar towards R2 bar. The B bar here will be out of the plane. So the field will be out of the plane, where at point P2. You have to show the direction also. What about at this other point? It will be into the plane here. On the negative y-axis, here the field will be into the plane. Like that, till where the field will be. Put R equal to infinity. So in a space, it will be spread. Till infinity, what happens? This field will be present. So a moving charge particle will generate a magnetic field. Actually, we have to start from here. The charge particle like this, when moves in a wire, the resultant of that all will be the what the Biot-Savart law. So, but what happened? The Biot-Savart law didn't start like this. It was an experimental for them. They were doing one experiment. Whenever they were doing experiment with the Lagrange or Daniel's cell. So whenever every day when they're coming and switching on the equipment, there was a compass needle nearby this wire, because usually in current density we take wires, no, to connect different elements. And whenever they were starting experiment or switching off that one, they saw compass needle got deflected. This happened for almost a few years. Accidentally one day, when they were switching on, their eye felt on the compass needle. It got deflected. Then they thought, oh, okay, some reason. Then next day again, switching on and off. Continuously they noticed there's a deflection. From where is the magnetic source? Then they started searching, is there any magnetic source? Nothing was available. Then at the varied current, then switch on and off, decrease current, the deflection needle was different. So then they made a conclusion as this current carrying wire producing magnetic field. Then they got Biot-Savart law. Then later on, the Biot-Savart law, with the help of that, it is modified. But actually, this is a fundamental, no? So we didn't start with fundamental. We first the law came, then next came the fundamental. Is that okay? So now, if you go for charge particle moving in magnetic electric field, yes, even the moving charge particle will produce B bar. If a charge particle moves in external magnetic field, there are two fields are there, no? The moving charge particle will produce its own field, and also there'll be external field. Sometimes they may mix up questions, huh? You have to be very careful.